All right, in this lecture, we're going to take a look at the formation of acetyl CoA and the Krebs cycle or citric acid cycle. So, we just finished looking at glycolysis, and we were left with pyruvic acid, if you'll recall. So, with pyruvic acid, we then have an option. If there's not enough oxygen present, the pyruvic acid will convert to lactic acid. In this process, then, an oxidoreductase will convert the NADH to NAD. Remember, we had an NADH. And transferase will form ATP from ADP. So we'll get 2 ATP if the pyruvic acid goes on to form lactic acid. However, if sufficient oxygen is present, what will actually then happen is we will then take that pyruvic acid and convert it so that it can enter into the mitochondrial matrix. So, with oxygen present, pyruvic acid enters the mitochondria and it's oxidized, and oxidoreductase is involved here. NAD is reduced to NADH, so this is what we're seeing up here. So you have one glucose, remember, got to our 2 pyruvic acids. It has oxygen, it's an aerobic pathway, so it moves in here, and then we then have another reduction that takes place, or oxidation reduction that takes place off of the pyruvic acid. So what we really have is the 3-carbon pyruvic acid becomes a 2-carbon acetyl molecule that's bound to coenzyme A. So that in this process, here's our 3-carbon pyruvic acid. We've entered into the mitochondria. Coenzyme A comes along, releases a inorganic carbon dioxide molecule, and in that process it binds to the 2-carbon molecule that we have left here. We have acetyl CoA. So this conversion gives us a couple of NADH. Remember, it's happening twice because we have 2 pyruvic acid, not 1, 2 from glucose. So it gives us 2 NADHs, 2 CO2s are liberated, and now we've got this acetyl CoA. So we're converting. So I don't usually list acetyl CoA as a product because it's the part of the process. For instance, in glycolysis, pyruvic acid is the product that's left from glycolysis. This is simply a conversion. Pyruvic acid to acetyl CoA, and what do we get from that? 2 NADHs and a couple of CO2s. So some waste, by the way. CO2 is part of the waste products. So if you want to know, hey, why am I always exhaling CO2? And you'll see there's more of it. This is a waste product of metabolism. This is where that comes from. Okay, the oxygen that you needed to make this happen helped to convert into CO2 by picking up the carbon. Okay, so that's what we had happening here. Just an intermediate step. This intermediate step is never on the exam. So I want you to, sometimes I ask a question about it, but this picture and this image are never on the exam for you to label. Do know that you get a couple of NAD because this is an electron carrier. There's energy in here we're going to use later on. Okay? And from there we move into what's sometimes called the citric acid cycle or the Krebs cycle. This is just one of those images for it. This is the image that might show up on your exam. So this looks very similar to the glycolysis image. It's a circular image. So we're now in this process, and taking a look here, we've entered, and I'm going to go actually back up 2 more. We're inside the matrix of the mitochondria. So what we're taking a look at, what's happening here, we've entered the mitochondria, the conversions occurred, and now throughout the mitochondria, it's not just happening once, but thousands of times within the mitochondria, you are going to actually have this citric acid cycle taking place. So that's what we're taking a look at here. It's shown to be circular because it actually, although not circular in shape, is a circular function. These molecules keep being used, producing things, generating energy, and going back and being reused again. So I didn't put the different enzyme categories in our picture here. That's probably more of an oversight on my part, and I apologize for that, but you'll have to label them in yourself. But in this one, the same type of process is going on, in that I will ask you to label the enzyme categories and the products produced. So again, when I put this on the exam, if this is the image that you get on the exam, I'll remove NAD and FADH2s, another electron carrier. I'll remove the ATP. I'll remove the CO2 production that's going on. I usually leave the names of the molecules here. And the reason I leave the names is just easier than trying to remove them. The COAs I sometimes leave in place too, because these coenzymes are just assisting in the reactions. So what you do need to know is that, remember we had that conversion, so now we've got an acetyl COA. This is where we say we begin. It's circular, so it's kind of hard to say where it starts or it ends, but acetyl COA is going to actually join with oxaloacetic acid. So this molecule of 4 carbons here is going to join with the 2-carbon acetyl molecule. And together, where they join together, and again, what enzyme category joins things together but a ligase? Ligase right here joins those together to give us a citric acid. So this is sometimes why it's called the citric acid cycle. It's really the first product of the series once the acetyl molecule comes in. So we go from citric acid to isocitric acid. So that alone hopefully should tell you it's simply a rearrangement. The term iso is a kind of a trigger. And so here, this step 2 is an isomerase, a rearrangement. You can feel fairly confident that anytime you see an NAD product being reduced here, any FADH being formed from FAD, that reduction, these all 4, 3, 4, 6, and 8, all of them are oxidoreductase reactions. Because what we have is this molecule here, in this case, isocitric acid, is being oxidized, NAD is being reduced. And in this process, CO2 is being released. Okay? Over here, in this one, the alpha-ketogluteric acid is being oxidized, NAD is reduced. Here, succinic acid is being oxidized, FAD is being reduced. Here, malic acid is being oxidized, and NAD is being reduced. So learn where these are occurring. So all of them, oxidoreductase, 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 oxidoreductase. Pretty straightforward on the enzyme category that's involved there. Okay, and again, CO2 is a waste product that is being liberated at this point in time. Coenzyme A is hopping on in there to help with this reaction. Forms a bond right here. This process here, it's coming in, it's helping facilitate the reaction that's going on. Okay, helps control the functions of the enzymes. Down here, we make our only ATP. Now, keep in mind, I'm only showing you the way this picture's been designed. It only has 1 acetyl CoA coming in, but remember there's 2. Because we had 2 pyruvic acids, this reaction happens twice for every glucose molecule. So, in this process, down here, with the help of a kinase or transferase, the phosphate is being added to the ADP to give us ATP. So we're making a little energy in this process. So we make a net of 2 ATP here, because remember we have 2 molecules. Then we've got an oxidoreductase, and then between fumaric and malic acid, we are simply rearranging, and you have another isomerase. Once this NAD is been reduced, we're back down to oxaloacetic acid, and another acetyl CoA can come in, and we can start this process all over again. So what the big picture that you need to see here is look at all of the NADs and FADH2s that have been produced here. These all carry energy. So I have the same PowerPoint here. I'm going to jump all the way back and remind you, from this process here, we got a couple of NADHs. That's energy being held on so we can grab it. Then we went down here and we converted acetyl CoA. We got a couple more here. And from there, we come over here to the Krebs, and we've got really 2, 4, 6 NADH molecules and 2 FADH2 molecules. Remember, this one is NADH plus H. Those hydrogens are liberated. In this case, we hold on to both hydrogens in our reduction reaction. But that's more chemistry than you even need to know here. Just know it's FADH2. But this is all of these, plus the previous ones, are all energy energy holders. We're now going to take those onto the electron transport chain, and now we're going to take that energy from that and finally be able to make our ATP. So this whole process has been, how do we take a glucose and get all that energy that was in all those bonds and somehow use it to make ATP? And this is the process our body goes through to make that. Okay, so that's our summary. And the next lecture then will take us into the electron transport system.